Hope you had a good weekend. So for our independent learning, I want to continue the idea of the concave mirror, but we're going to talk about a virtual image produced by it. So this will be pretty quick. I'm not going to take the time to draw. We can do that tomorrow. But if the object is far from the concave mirror, we learned that you can actually project it. And this happens when it's real images. It's real images because if I actually make an object out here, it's a real image mainly because these are the first light ray right here. These are the actual light rays that are being reflected. They're the actual ones intersecting. So when you go through your rays, we learned the first is parallel through the focal point. Second is just the reverse through the focal point, then parallel. And then if you want to check one for confirmation, just go through the center of curvature, then straight back. All three of these reflected rays intersect in front of the mirror right here. If it's the actual rays intersecting, it's a real image and you can project it. You did notice though that when we did this, it was upside down. It wasn't really clear when I did it with my window, but we confirmed it hopefully with these ray diagrams. All right. When you move the object closer to the mirror, so when I took the little Lego guy, even we did Michelangelo, I'll try to keep this height the same, it can adjust. When I moved it closer, you notice the image was still upside down, all right? But I think it was Brianna said it's getting bigger. So you can see the height of this, not drastically, but the height of this is getting a little bit bigger. And what you may not notice as much though is that its distance from the mirror, where it's actually being shown and focused, it's changing as well. All right, when you get to the center of curvature, it'll actually be the exact same distance you are from the mirror, so double. That's the only location though. And then when I do get inside the center of curvature, the image does start to get bigger. It's still inverted though, and it's still the actual light rays reflected, so it's still a real image. What I didn't talk about then is what happens when you get at the focal point or inside. Well, at the focal point is not really what I intend to talk about today, but when this happens, if you go through the rays, the three rays that we draw, you would go parallel through the focal point. Then you would go through the focal point, which they don't show, but that's straight down. And since it didn't hit the mirror going this way, your only option is to then reverse directions, but you wouldn't hit the mirror that way as well. So the second ray doesn't even hit the mirror, and you'll notice the third ray, the center of curvature, it basically ends up being parallel with this reflected ray. So long story short, the reflected rays never intersect. And keep in mind, there wasn't even a reflected ray for the second one. So this is one unique location where an image doesn't even form. All right, it would be really blurry. And hopefully you maybe noticed that with the spoon if you could, or we saw with Leonardo, he disappeared. Once you get inside of this though, and here comes the big thing for today, once you get inside of this, an image then reforms. I'm going to go to this spot. It's pretty nice. But you'll notice right away the image is behind the mirror. Right away when I see that, I know that light can't actually get through a mirror. It's not like you can see through mirrors. So that means that this is not formed in front of the mirror. It's behind. You can't project it because it's not the actual light ray. So this is virtual. So going through the light rays, you'll notice we would have gone through the focal point, but we never would have reached the mirror this way. So we would change directions, hit the mirror, then go parallel. So there's these little rules where if you can't reach it going one way, you got to reverse on that same path the other way. Second ray is still okay there. It goes parallel then through the focal point. And then the third ray is fine too, except again, go through the center. We got to reach the mirror though, so we got to backtrack this way. What you'll notice though in this chaos is that the three reflected rays, first one here, second one here, and third one here, they'll never intersect. So we did this with the flat mirror. We basically recognized, well, if they don't intersect here, we can then backtrace them behind the mirror. It will then, of course, form the image behind the mirror, which means the only way you can see it is to actually look into the mirror. All right. On the canvas, I then asked some questions like describe the loss. All right. The location, orientation, size, and type. If you are a bit confused with what that is, you can always refer to the problem we did last week and also use the textbook to help yourself out. That's a good diagram on page 739. Okay. All right. Be ready to talk about this tomorrow, and I will see you guys Wednesday.